Assalamu alaikum wa rahmatullahi wa barakatuh. Students, this is Masood. Today we are going to see the fourth exercise of our electrical technology lab. So the fourth exercise of our lab is related to the testing of single phase transformer. The type of testing what we have done in the third exercise in the previous lab classes, direct loading test of transformer. Now we are going to do the indirect loading test of single phase transformer. What is meant by indirect is without the physical presence of load. By assuming the transformer is loaded, we are going to test the transformer. Okay. In another way, it is called as predetermination test. The actual name of the test what we are going to do is open circuit test and short circuit test of single phase transformer. Okay. So by doing open circuit test, we are going to test the transformer, and by doing short circuit of the secondary side in the transformer, we are going to test the transformer. Okay, so that is what it is called as OC and SC test in short. So why we are doing this? What is the aim of this exercise? To predetermine the efficiency and voltage regulation of the transformer, and also to find the core loss and full load copper loss of the single phase transformer. So by knowing those two losses, we can find the output, we can find the input power, thereby we can get the efficiency by indirect testing method. Okay, so without any load, without the physical presence of load, we are going to reach the efficiency of the single phase transformer. So now we are going to do two tests in the transformer. It is open circuit test. First, circuit diagram for open circuit test. So this is the circuit. As you know, this is the second exercise you are doing related to the transformer. We are having a auto transformer for changing the input constant voltage AC supply into the required output variable AC voltage. For that we are using auto transformer. We are using a wattmeter to measure the wattage. In addition with it is a digital type wattmeter, so it will read out the primary voltage and primary current, and this is the transformer whose efficiency is to be predetermined by doing OC SC test. So we are going to conduct first open circuit test on the transformer. Open circuit means the secondary circuit will be opened, will not be connected with any load. And according to the circuit diagram, the rating of the transformer what we need is 220/220. So the primary voltage also 220, secondary voltage also 220. So in the primary side, in the physical transformer, in the primary side we have a 220 volt tapping, but in the secondary side we have two coils each rated for 110 volt. So we have to connect it in series. So how to connect it in series? So series means end to end connection. The output end of first coil is connected to the input end of the second coil, so that across the another two terminals we can get 220 volt, and the voltmeter we need for reading out the secondary voltage. Okay. So this voltmeter will read out the secondary voltage, and now we will get into the circuit diagram of short circuit test. Okay. So we are now going to see the circuit diagram for short circuit test. So short circuit test, the same thing, same equipments we are going to use: auto transformer, a digital wattmeter, and the transformer of course which is to be tested, on which we are going to do the SC test, and the two coils to be connected in series to get 220 volt in the secondary side, and a clamp meter to use it as an ammeter for finding the short circuit current. To do the short circuiting in the secondary side, for measuring the secondary short circuit current, we need a ammeter. So for that we are using a clamp meter as an ammeter. So the connections about OC test. So these are the equipments we are going to use. It is shown to you as a circuit diagram, and it is shown here as a table work exercise, table work finishing. Okay. So now you have to give the complete the circuit diagram as given. So we have to connect the auto transformers output phase terminal with the M point as like this, and the MC short circuit, and you have to connect the L point with the 220 volt tapping of the primary coil, and 0 point of the primary coil is connected to the wattmeter V point, and V point is again connected with auto transformer's output neutral point. Okay, so the connection up to this, it is same for load test, it is same for open circuit test, it is same for short circuit test also. So in the primary side, the connection is same for all the three exercises, for all the three tests, it is same. In the secondary side, we are just going to connect the voltmeter to measure the secondary voltage during the open circuit condition. That's all connected. So it is an animated video. So we will actually see how the connections in the work table as a video. Next is about the circuit connection for SC test. So for SC test, how the connections is going to be given, it is like this. It is a circuit diagram picture, and this is the table work picture. And as I said, in the primary side, the connection is same between all the three exercises. So the same circuit, same connection is followed in the primary side, with a small change in the secondary. Instead of voltmeter, now we are going to use an ammeter in the secondary side. Just short circuit the secondary side 2 points, that is 220 volt point and zero potential point, and connect a clamp meter along the wire. Just connect a clamp meter along the wire. Okay, so open the clamp meter hook and just clamp it along the wire. That's all. So now the ammeter is connected along the secondary short circuited wire. Now we will go into the conduction. So during the conduction, I will explain you. Now we will see the video about the connection. Okay, open circuit test connection we are going to see. So already you have seen the animated pictures, animated video. Now it is an actual video on the work table. So the auto transformer is given with the supply through the lead sheathed cable, and the output phase terminal is taken and connected to the M point of the wattmeter. So M and C are short circuited, and L point is connected with 220 volt tapping in the primary winding. Okay, 220 volt point in the primary winding, and zero potential point, zero voltage point is connected with the V point of the wattmeter, and the V point of the wattmeter is connected to auto transformers output neutral point, output side neutral point. Okay, so again I am saying this is the connection you have to follow for all the three tests, whether it is a load test or short circuit test or open circuit test. Now coming into the secondary side, we have two coils, each rated for 110 volt. So to get the 220 volt coil, single coil, we are going to connect it in series like this. So now the coil is connected in series. So this point is 220 volt point, it is connected to the voltmeter, and the voltmeter's neutral point is connected with zero potential point of the secondary winding. That's all about the connection of OC test, open circuit test. The same connection is going to be followed for the short circuit test also, with the meter to be changed in the secondary side. So as it is same, I am just showing you the video of secondary side connection. Okay, the secondary circuit connection I am showing you as a video. See, first the secondary coil is short circuit series connected. The two individual secondary coil are seriously connected, and single wire is connected between the 220 volt point and the 0 point, and the clamp meter is connected along the wire. Okay, so this is how the connection for short circuit test. Now we will go into the conduction and tabulation of open circuit test. So this is the slide about OC test conduction. We are going to conduct the open circuit test. So the primary winding is rated for 220 volt. So switch on the supply for the auto transformer and gradually increase the auto transformer's output so that your primary wattmeter reads 220 volt. Reads 220 volt. So this is done without any load in the secondary side. So it is called as open circuit test. Okay. You can see there is no load, only the voltmeter is connected in the secondary side. So you can see the voltmeter reading, and now you have to tabulate the readings. So V1 is noted in the given table. V1 220.8, V2 231.2, and I0. This is called I0 because it is no load test. Already we seen this. And the wattmeter reading is taken. You can see it to be 13.1 watts. Okay, you can see it to be 13.1 watts. You can see the wattmeter reading to be 13.1 watts. You have to know what it is. So what is this reading is the core loss of the transformer. This we have seen in the theory itself. When you open circuit the transformer and when you check the primary power consumed by the transformer, it will be the core loss, that is no load loss, which is the another way called as constant losses. Okay, so there are two losses inside the transformer. The two losses added up and it is getting into a value called 13.0. Okay, what are the two losses? So just for your remembrance, I am saying it is hysteresis loss and eddy current loss. These two losses added up and it is constituting the core loss of the transformer. This core loss will occur in the transformer even without load on the transformer. Okay, even without load on the transformer, this core loss will come into the transformer's picture, transformer's operation. Okay. So the open circuit test will give you the no load copper loss of the transformer. And in the short circuit test, what is happening, we will see. So now we are going to see about the short circuit test conduction. How to do the short circuit test. So the connections are given as per the circuit diagram, and now you have to remember what you have done for doing the open circuit test. We have supplied the rated voltage in the primary side of the transformer for OC test, for open circuit test. We have supplied the rated voltage. In short circuit test, what we are going to do is we have short circuited the secondary. Now we are going to vary the auto transformer such that in the secondary the rated full load current is circulated. So in the short circuited side, we have short circuited the secondary. In the secondary, we have to supply the rated full load current. For that, we have to first calculate what is the full load current. So in the open circuit test, it is written 220 volt in the primary side rated voltage, so we have applied the 220 volt directly. But in the secondary side, there is no current written in the nameplate detail, so we have to calculate from particular equations. So what is the equation? So the rated full load current on the secondary winding is equal to secondary or primary. The same equation we have to use. VA rating divided by secondary voltage will give you the rated secondary current, full load current. If you divide by primary voltage, then it will give you the primary rated current. Now we have short circuited the secondary side, so rated full load current on the secondary winding equal to VA rating divided by secondary voltage. The VA rating you can see to be 500 VA. The transformer what we are using is about 500 VA rating, and the secondary voltage is rated for 220. If you divide, you will get 2.27. Now note this current. We have to switch on the supply and we have to vary the auto transformer such that this calculated, that is rated full load current, is circulated in the secondary side, in the short circuited side. Okay, now we will start. You can see the connections are given as per the circuit diagram. The table supply is on, and ensure that the auto transformer is at minimum position. ensure that auto transformer is in minimum position. Now you can switch on and gradually, slowly, very slowly vary the auto transformer, because the current will increase very steeply. Okay, so gradually, very slowly vary the auto transformer such that in the short circuit, this is the meter which reads the secondary short circuit current. Okay, so make it to be near to 2.2. Okay, nearly 2.27. Okay, so 2.27 it is circulated, and at this condition you have to note down what is the primary parameters. What are the primary parameters of short circuited test is, we have to note what is ISC in the primary side and the secondary side, and we have to note what is the VSC, what is the WSC. So here you can see, so IFL is calculated in the log report also, rated VA divided by secondary voltage or primary voltage. So if you divide by primary voltage, you will get the primary current. If you divide by secondary voltage, you will get the secondary current. Of course, our transformer is of same voltage rating in the primary and secondary side, so you will get the same value. Okay. So after supplying 2.27 amps, note down what are the primary parameters: VSC, which is the first value, and ISC, second reading in the meter, and the third reading is ISC2, about 2.27 amps, and the fourth reading, last important reading, is to be WSC. So WSC is nothing but, as I have explained to you in the OC test itself, the open circuit test is conducted to find the core loss in the transformer. Open circuit test conducted to find the core loss in the transformer, and the SC test is conducted, and the output, the wattmeter WSC reading will indicate you the full load copper loss. The WSC reading will indicate you the full load copper loss. So in the theory we have discussed, there are two losses in the transformer. One is open circuit, there is core loss and copper loss. These are the two losses. Once you find these two losses from the MVA, you can calculate what is the secondary output power of the transformer. So by reaching the output, we can calculate the input, and then we can calculate the efficiency. That is, we can predetermine the efficiency before applying the actual physical load. That is why it is called as predetermination. Without supplying or applying the physical direct load, we are going to reach the efficiency in terms of through core loss and copper loss, because these are the total two losses in the transformer. After reaching these two losses, by calculations we can reach the efficiency of the transformer. And after doing the test, we have to make the circuit return to initial position, reduce the auto transformer, switch off the auto transformer supply, switch off the table supply. Okay, this is how we have to conduct the open circuit test and short circuit test. And from open circuit test we can get the core loss, and from short circuit test we can get the full load copper loss. With these two losses, we can calculate the output power of the transformer by the VA rating and the secondary power factor. After reaching the output power, we can add these losses and output power to get the input. So output power divided by input power will give you the efficiency. Okay.